Informatics as information processing science. In this slide, you mostly are watching the European understanding of informatics. In the first bullet, it says in the early 1990s, an interpretation of informatics as a fundamental science is proposed. So, since they want to have it as a science, of course, not everything is about application. So, the same way we have it in the definition I just gave you about the origin of informatics in the United States. You remember that when we talked about computer informatics, we said in Europe it is considered mostly close to what I know that we know as computer science. So here it says in 1990 they get their independent interpretation of informatics as a science. So they distinguish it in this way that studies information processes in nature, society, and technical systems. So it is not just about calculations, in fact, artificial calculations that we know in informatics. A broad interpretation of informatics as the study of structure, algorithm, behavior, and interaction of natural and artificial computational system. So you see how much the texture of this definition is different from the previous slide that we talked about, because they were mostly professional, application based, but here it is science based. For example, here it talks about the structures. Here it's about creating algorithm. Here it's talking about behavior. Here it talks about natural computational systems, something that we absolutely are not considering in our program, in our definition of computer informatics. And so that was the reason that we decided to change the name of the program from computer informatics to eliminate any misunderstanding of what this program is about in a college of business. And finally, it talks about the fact that the institutes of computer science, pay attention, Institute of Computer Science, Artificial Intelligence, Cognitive Science, three big institutes, departments were merged into a single school of informatics. All these things happens at the University of Edinburgh. In the previous one was 1994, and in 2002 they combined computer science, artificial intelligence, cognitive science into School of Informatics. So you see how big and impressive the name of School of Informatics is, and it encompasses all these departments. And again, I'm telling you about all the background to understand exactly what you are supposed to do and learn in your program. And here you can see. Here you see the School of Informatics at the University of Edinburgh, and it is combination of that three department that we just talked about: computer science, artificial intelligence, and cognitive science. And you may ask yourself why there is need for combination of the things to come with School of Informatics based on what we discussed together. Because remember, there is a main difference between what we are doing in the Department of Computer Informatics and what they are doing over there. We are focusing on applications. We are focusing on learning the product that are over there and learn how to use them as business people. But over there, they try to develop these algorithms, these structures. So they need to have a pure understanding of the science behind them. To wrap up our class today, I have prepared some examples for you in the field of data analytics, or again, computer informatics, with the American definition for you here. Here you see an exact example of all the things that we discussed. Here we have a database, one part of any informatics. Over here, we have a data analyzer. It has been generated based on the data that you have here. This one that you see on the right is a computational system, logical computational system. Why? Because it works like this. See, here it is to solve a problem. It solves a problem of categorizing bank customers as defaulted or non-defaulted. They have the database of 10 previous customers, and they have 3 attributes that you are going to learn about these things very well in the coming years. And based on these attributes, they decide if that customer is defaulted, yes or no. So you see, this computational system, this logical computational system on the right, solve a problem. Okay, just imagine we have a customer, we have a client comes to our bank, and he is not a homeowner. Okay, the system wants to try to categorize it as defaulted, yes or no. So from homeowner, since it is no, the system comes here. It checks its marital status. Imagine it is single. So the system comes here. And after that, it checks its income and assume, for example, the income is less than 80K. So it comes here and it categorizes that person as defaulted no. Remember, it's just an example. Don't follow any logic in the data that you see here. Okay, they are randomly generated to solve these things. So you see what we did here were some logical operations: equal, greater, or smaller. Why it is an example of informatics? Because it transformed this information here to this type of analyzer that can help us to solve a decision, to solve a problem. Why it is computational system? Because as you see, it's completely based on logical operations. In real life, instead of 10 customers, You have 10 million customers to generate such a thing, and they are something that they are being applied in our everyday life. Let's go for another example. And by the way, you as a computer informatician, you as a data analyzer are not expected to change the rules of developing a decision tree. No, it is not your responsibility. It is not the expectation from you. The expectation from you is that to know what is decision tree and, like an artist, know when you should learn this great tool to help to help make better decisions. Let's go for another example. In another example, you have data. What is your data? Just imagine the data in a Walmart branch. Okay, they have 5 transactions here. In real world, instead of 5 transactions, it is 5 million transactions, for example, per day. In the transaction 1, it is bread and milk. Transaction 2, bread, diaper, beer, and egg. So again, based on this data, we have some technique that you give this data to the technique and it gives you some recommendations. So if a customer buys diaper, it recommends buying beer. What is the base of all this recommendation? They are calculations that we are going to learn all the things together in the course Informatics 450 and 451. But here I'm introducing you to what are the type of things that we are doing. When I'm saying we are going to focus only on application, it doesn't mean we are not going to do great things, because it is the base of recommendation system in the billion e-commerce business. So you as a informatician are expected to know about the things and know when you should use them. And as another example, I don't want to bore you with the example. Here is an example in the field of healthcare. Here is an scan of a brain, and here are some calculations that you, when the scan is available, the calculation is here. And finally, it based on these 3 indices, it decide if the scan belongs to a benign problem or malignant. In real world, instead of 24, we have millions of examples. In real world, instead of 3 indices, we have 100 indices. So how they are going to do it? They are going to do it with neural network, artificial intelligence. Absolutely, you are not expected to create learning algorithms for neural network. You are not expected to improve the performance of neural network by changing the structure or working on the mathematical foundation of these things. You are just expected to know the general points about neural networks and know how to run them. Exactly like driving a car. When maybe you are a wonderful driver while you know nothing about the mechanics of a car. But nobody expects a driver to know about mechanics of a car. They want you to have a good control over that car. Okay, I think we are good for today, and I hope you find it interesting, this first session that we talked about the general, very general aspects of our major. Please feel free to contact me if you have more questions or want more discussions. Thank you.